Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections using the Solid Edge software. In this problem statement, we have a hemisphere of diameter 40 mm, which is supported co-axially on the vertex of a cone whose base diameter is 60 mm and the height is 50 mm. And also, the condition is the flat surface of the hemisphere is facing upwards. And we need to draw the combination of the isometric projection of the solids. So now let us understand that there are two types of solids. The first being a hemisphere whose diameter is 40 mm. So we already know that hemisphere is nothing but a half part of a complete sphere. And this diameter is 40 mm. It is standing coaxially on the vertex of a cone. And coming to the cone, there are two parameters defining it. One is the diameter of the base of the cone, which is equal to 60 mm, and also its height, which is equal to 50 mm. So with this data, first let us do the orthographic projection of the combination of the solids, and then let us take the details from that to complete the isometric projection. So let us begin by constructing the xy line whose thickness is 0.18 mm. So this is the reference line. So let us first complete the top view of the combination of the solids. So go for a line whose thickness is 0.50. So we do know that the top view of the cone is a circle. So on any arbitrary point, considering it to be the center of the circle, draw the circle whose diameter is 60 mm. And this marks the top view of the base of the cone. And also we know that the flat surface of the hemisphere is facing upwards. So that means again in the top view, the hemisphere will also be seen as a circle whose diameter will be equal to 40 mm. So this is the meaning of coaxially. That means the axis of the cone and the center point of the hemisphere are coinciding. So this is the top view of the combination of these two solids. So select the line option with thickness 0.13. So just place the cursor and draw the diameter of both the solids. And from the endpoints of these diameter, let us draw the projection lines, intersect that with the xy line. From the center point, again draw a projection line, intersect the xy line. So now let us draw the front view. So we do know that from this point, the center of the combination of the solids will emerge. So the first solid here is a cone, and the height of this cone is equal to 50 mm. So draw a line whose length is 50 mm. So again go for the line option, select a continuous line whose thickness is 0.50. So from the apex of this axis line, join the endpoints of the cone. So this is the true slant generators of the cone. So this completes the front view of the cone. Again, we need to draw the hemisphere here. So for that, we need to understand that the diameter of the hemisphere is 40 mm. So the radii from this part to this part will also be a part of the axis. So again, select a line of thickness 0.13 and again select the axis line. So from this vertex of the cone, draw a line of length 20 mm because the diameter is 40. So the radii will be equal to 20. So this part is with respect to the hemisphere. So now again select a line which is continuous type and select a line whose thickness is 0.50. So from here 20 and also from here 20. So this 40 mm marks the front view of the hemisphere. So the flat surface of the hemisphere which is facing upwards. So let us go for the circle. Select this point as the diameter, the center of the circle. So draw a circle whose diameter is 40 mm. Go for the trim option and trim the upper part of the circle so that you get a hemisphere. Also, if you just use the extend to next option, so if you just try to draw the projection lines of the of the hemisphere from the top view, you can just see that you get the projection lines here. So let us just try to extend these projection lines. You can just see that they're all meeting exactly. So this is how you do the combination of the solids. So this is the orthographic projection of the combination of the solids. So go for the smart dimension. Just indicate the dimension of this. So this is having a diameter of 60, and this is having a diameter of 40. Also, the height of this cone is 50, and this is 20. So since the diameter is shown here, again you need not have to show that the width of the hemisphere is 40 in the front view again. So in the front view, it is just enough for us to represent the axis dimensions. So select the annotation, annotate the reference line as x and y, and also the planes as VP and HP. So with this, we complete the construction of the orthographic projections. So now we need to draw the isometric projection. So to draw the isometric projection, we need to place this circle inside a square so that we can construct a square of that dimension and then start constructing the circles. So let me select the line option again. Select a line of thickness 0.13. I'll be using a different color line here so that we'll be able to differentiate the different circles that we are going to consider to construct. So let me select the color of blue. So the outer diameter, the outer circle represents the top view of the cone. So this has to be placed inside the square. So from this point of intersection, let me just intersect this using the blue line. So you can just see that the diameter is 60. So let me just draw the circle, square also of 60 cross 60, and enclose this entire outer circle inside the square. So this is how I need to construct. So just go for the smart dimension and then select these two lines. You can just see that the square measures 60 here. So it could be a square sometimes, or it could also be a rectangle sometimes. So this is 60, and again the distance between these two parallel lines is 60. So I need to construct a square of 60 cross 60 and then construct the base of the cone. So for that, let me select the line option again. Let me switch over to the black color. So let me draw a line of any arbitrary length. So from any arbitrary point on this line, I'll start constructing the square in the isometric scale. So let me construct the square first in the true scale, and then let me convert that into the iso scale. But in the isometric sheet, the iso scale will be considered for construction. So here the dimension is 60. So I'll be drawing a line of length 60 mm and the angle 30 degrees. But in the isometric sheet, directly you can draw a line covering the 6 boxes. And this is again 60, and this is 60 again. The angle is minus 150. Then complete this. So you can just see that the angle here will be equal to minus 30, but I guess there is an error with the angle here. So just go for the angle between this two. So it is 128. Change that to 120, and then here it is 60. So now this will be correct. So the dimension would have varied for the line. Okay, it is 60. So go back to the line option again and complete the square. Minus 30. Okay, so the angle here has changed. So go for the angle between. Select this 30. Okay, so the dimension of this line will be 60, and this is 60. So a small error can change the dimension of the entire connected lines. So now you can get a correct line. So just 60 and minus 30. So the endpoint has connected. Okay. So let me just remove the dimensions of all this. Okay. So now I've constructed the square on the isometric sheet. So that is 30 cross 30 lines. So now I need to mark the circle. So to get the circle, the next step is, let me draw the diagonal first. So from this point, I need to select the midpoint of the opposite edges. So for that, go for the IntelliSketch, click on the midpoint and click OK. So from here, connect the midpoint of this edge, and from this vertex, connect the midpoint of this edge. Similarly, from here, from this corner point, connect the midpoint of this edge. From this point, connect the midpoint of this edge. So we'll be constructing the circle using the four center point method. So we have got four centers now. So this is C1, this is C2, C3, and C4. So now go for the arc by center point. Select a line of thickness 0.50 mm. So keeping this point, that is C1, so just draw a circle connecting this. So this marks the first step. Next, we have got the center C2. So this is C2 and this is the radii. So just let us construct an arc. So either this edge or this edge, anything you can choose. So this is the second arc. So now we have got the point C3. So from here till here, so just sweep an arc. So this completes the C3 circle. From C4, let us draw an arc. So this completes the circle, which is the base of the cone. Okay. So if you are getting confused, you can just see that I'll change the color of this square to blue color so that you can understand that this square has been constructed and then the circle has been constructed within the square. So now we need to understand that the height of the cone has to be constructed. So for that, let me select a line of thickness 0.13. So from here till here, let me draw the line. So I get the center point of the square. So from this point, I need to draw a line of length 50 mm, which is the height of the cone, and the angle will be equal to 90 degrees. So in the ISO sheet, you have to draw from here 5 boxes covering the height of the cone as 50 mm in the ISO scale. So now we need to consider the line option again. Select a line of thickness 0.50. So from this end point, just draw this line touching the circle. So just let it be a tangent. Do not get it here connecting any point. So just draw a line tangent to the circle that we have constructed. And then we shall just go for considering the split option. So you can just see that I'm going to split this, or this part of the circle has to be made invisible. So let me just go for the split option, select this arc, and from here I will split this. Similarly, I'll select this entire arc, and then at this point I'll be splitting this line. So now you can just see I can select this entity as well as this entity and this entity. So this part of the circle will not be seen. So this is 0.13 mm. So this is what is the cone, correct? So this is all having a true dimension. Later on we can reduce the scale to 0.816. So before we do that, let us construct the hemisphere. So now again, go for drawing a line of length 20 mm and ensure the thickness of the line is 0.13. So here again we need to draw the circle. So this is line of length 20 mm. So again here draw 20 mm. The angle is -30. Similarly, from this point 20 and the angle is 150. So you get this line. So in the isometric sheet, you will draw two boxes here, and from here two boxes, two boxes. Similarly, from this point 20 mm and the angle is 30 as shown here. And again from this point 20 and the angle is -150. So we complete the midpoints of the square. So now let us just join this. So again from here 20, angle is 30. So from here draw a line of length 40 mm, an angle of -30 degrees. And from here 30 mm again, and the angle is -150. Okay, the line should have been the length of 40. So let me just change it here, 40 minus 150. Similarly, from this point again, let me draw a line of length 40 mm and then complete this square. So this is to draw the circle of the hemisphere. Okay, so now let me go for the uh, orthographic projection. So I'm drawing this circle. So let me just enclose this circle and make you understand why the square was having a dimension of 40 cross 40. So let me select a line of thickness 0.13, select a red line here. So from this endpoint, I'll connect this, enclose this circle. Again, 40 mm, angle is minus 180. Then 40 mm, then connect this point. So this circle is what I'm going to consider constructing on the vertex of the cone. So for that, go for the smart dimension. Let me select this point and this point. See, this is a square of 40 mm. Again, similarly, this point or this line and this line. So it is a square of side 40 mm. So I've constructed a square of side 40 mm on the vertex of the cone to draw the hemisphere. So let me get back to the isometric construction. So we'll construct the circle in order to avoid confusions and to make you understand the similarities between the orthographic and the isometric. I'll change this color to the red so that you'll understand the same square has been constructed here. So this is the bottom square replicating the base of the cone, and this is the top square replicating the flat surface of the hemisphere, which is again a circle. So again, let me go for the line option. So from the vertex, let me just join this line, join the diagonals. Okay, it is all red in color. Let me just change the color of the line to black. Okay, so from again, let me follow the force enter method. Let me use the trim option, trim these lines. Let me draw the lines, the diagonals of the square. So from this point, I need to join the midpoint. So the midpoint is here. From this point, join the midpoint of this opposite edge. From here, midpoint. From this line, join the midpoint. So you have to get four centers: center 1, center 2, C3, and C4. So now let us go for constructing the circle. Select a line of thickness 0.50. Ensure the color is black. And then from here, let me select arc by center point. So this is C1. The radii of the arc is equal to this. And just let me sweep a arc connecting these two edges. Similarly, from C2, consider this as the radii and then sweep an arc. Then from point C3, select the intersection point carefully. Sweep the arc from C4, this being the radii, sweep the arc. So you get the circle, which is the top surface of the hemisphere. So now let me go for the arc by center point again. So we'll follow the manual construction method, taking this as the radii. I'll just consider drawing the circle. Let me use the trim option. Let me just trim the upper portion of the circle that I've drawn. So this is the hemisphere. So now let me select the entire object and reduce it to the iso scale. So because all this is in the true scale, let me select the entire combination of the solids. Go for the scale option and enter the scale value as 0.816. 0.816 as the value, and then place it back to the same point where you have started. So maybe the circle or the square was not selected completely. So let me just deselect this entire thing. Go for the scale option. Enter the value of the scale as 0.816 and then place it. Ensure the copy is off when you do this process. So now this completes the combination of the solids in the iso scale. So to show the dimensions, you can just see here now it has been reduced. So the actual height in the true scale was 50, but now the ISO scale has been reduced to 40.8, but in the isometric sheet it will be equal to 5 boxes. So you can just unlock this, enter it as 50, and show that it is the ISO dimension. Similarly, we have got the hemisphere here. So the construction lines can be erased. As per the standard procedure, we are not supposed to show any of the construction lines for the isometric projections. So you can just delete all this and just show the combination of the solids. And the hidden lines also has to be not shown. So this is the actual representation of the solids. So this is the actual isometric representation of the combination of solids, where we have got a hemisphere of radii 40 mm resting co-centrally on the axis of the cone whose base diameter is 60 mm and the height is 50 mm, in such a way that the top face is being upwards. So this is the isometric combination of the solids. So with this, we complete drafting the solution in both the isometric as well as the orthographic. So it is always mandatory for us to draw the orthographic projection and then move towards constructing the isometric projection. Thank you all for watching.